And once you have this part of your answer, x equals 3, you could take it and plug it into your original equations. You could technically plug it into either one. I'll just plug it into the top one. So 3 plus y equals 4. So I'm taking this equation over here and plugging it into x. And then y equals 1. Because this is an x comma y coordinate plane, you kind of want to put it as a coordinate point. So your final answer is 3 comma 1. I don't know why I wrote 4. 3 comma 1. You want to write your final answer in a coordinate point if it's x and y. We'll do word problems sooner or later. Those you don't need to write in a coordinate point. Leave that up for like a couple seconds. Anyone have any questions, just speak up. Okay. Everyone try this one yourselves. Everyone practice this one. You can send me the answer privately. This is not your exit ticket, so please don't leave if you get it right. I just want you to have some practice yourself. So just send me your answer privately so I can check it. Moses. Once you get an answer, you can just privately message me inside the chat. Well, it doesn't give me a notification anymore. Interesting. Dylan, David, Rebecca, good. Sarah, are you distributing correctly? Because you shouldn't get a decimal point.
Wait, no, probably not.
So yeah, check that. That might be a possible mistake. Lexi, good job. Zach, no, Zach is not true. Jacob, negative 3.2. What is that? Just write it as numbers, man. Brandon, you're good. Haya, you're good. Nate, your y is good, but you just mess up on you subtract 4 on both sides, not add 4. It's a positive 1. So it should be something else. Nate?
Yeah, got you. My bad.
Yeah, no problem. Leia, you're good. About 30 more seconds. So I don't think your class will have problems with Sarah, no. Solve for y first, Sarah. Try to solve for y first. So get x by itself. That will make your life a lot easier. Wait a second. Oh, shoot. I'm gonna grab the scroll wheel of a pen. Zach, good. Yossi, good. Hannah, good. All right. Okay. So for this one, what's really important is that you kind of want to isolate the one with least resistance. So for me, the least resistance is the x. There's no variable next to it. If I wanted to separate the 2y, I would have to divide everything by 2, so y is by itself. And that makes fractions, and that makes it a lot harder. So try to isolate the one by itself. But you do your workout, basic algebra, 2, -3, -3, comma 2. So that's substitution. Does anyone remember offhand what the other common one we use? Starts with an E.
I forget what it calls, but it's the one where you make it so that one of the two is equal and then you add them together.
Good.
'Cause-
It is. Yeah, you're trying to eliminate one of the variables, so we call it elimination. Okay.
Oh, sorry. Yeah.
No,
Yeah, that's
yeah,
the
you
technique
don't.
I used.
Yeah. So elimination's the common term, at least. Maybe there's another name for it. But you typically want to add or subtract in order to get it rid. A lot of people, or I don't know who teaches it. I think Miss Carson teaches it. As to multiply to -1 and then make them both the same sign and then, or different signs and subtract. Add it. Usually, go ahead. Nick.
I
Yeah.
think it's you could subtract it so it would go away. So if you wanted to make it, or you can multiply by any number. It doesn't have to be -1. So let's say you wanted to get rid of the 3x at the bottom for the second problem. You can multiply them both 6x, and then the bottom one by all of the top. We multiply by 3 every single number. So it'd be x minus 9x, whatever it is. And then the bottom, you would make it times 2. So then you would get the right -2. So then you would be able to subtract them.
All right, perfect. You guys do remember this stuff. I just want to say, as me, I usually, if they're like the both same signs, I would just subtract normally, but you could just multiply one of them by -1 so you could add. To me, I don't care which way you do it though. I'm just telling you up front. So if you see like, oh, that's a little different than I do it, just know that's why. And I'll try to explain that as best as I can. For these, that won't occur, but I could show an example in the future. Anyway, so for the top one, what's pretty nice is that you're trying to get one of the variables to match, as Nate said. In this one, on the top one, though, number 1, let's say, it's already done for us, 2 and -2. So since the both y's are both 2, if I were to, because one's positive, one negative, you add them together. So 3 plus 5 becomes 8x. 2 and -2 becomes 0y. So because that's 0y, we don't even need to write that. I just write 0y just to indicate that disappeared, but you don't even need to write that. And then equals, don't forget, this is a very common error, don't forget to add that last column too. So 4 plus 8 is 12. Then you do a little bit of math. X equals 3/2. You could think of it as 1.5. Will you get decimals? Yes, you will get decimals. These questions will allow you to get decimals. But since we found one of our x's, we could choose either equation. I like the equation with no subtraction. So 3 times my found value, 3/2, plus 2y equals 4. If you want to change this into 1.5, you can see that it's 4.5 plus 2y equals 4. Subtract 0.5, 2y equals 0.5, because I will subtract 4.5 on both sides. Divided by 2, divided by 2. Half of a half is 1/4, so 0.25. If you did it all in fractions, it'll be 1/4. So your final coordinate point is 3/2, comma 1/4. You can leave it as decimals also. And I'll just write that. 1.5 and 0.25. Both are okay. This bottom one, as Nate mentioned, we're going to have to make them the same. Now, if you make the x's the same, you have to multiply both. I prefer to do the move of least resistance. So what I'm going to do is multiply only the bottom by a 3. It doesn't matter if you multiply both or single. It doesn't matter which one you eliminate. As long as you do it correctly, you'll always get the right answer. So you don't have to worry about choosing the wrong way, but try to minimize the work on yourself sometimes. So you could choose, there's always an efficient way, but there's no real wrong way unless you just do it wrong. So the bottom one, I multiply everything by 3 Again, very common mistake. Everyone forgets that third term, the constant on the equal sign. Once these are the different signs. So if I add them, they will disappear. So I have 11x equals -22. Simple algebra, x equals -2. Then we take the x equals -2, plug it into one of our original equations. You can technically plug it into this multiplied out equation, but that's always going to be a little bit more work because you're dealing with bigger numbers. So just plug it into one of your original equations. I'll plug it into the top here. So 2 times that -2 that I found.
Mr. Well, I did it. I mean, I'll wait till you're done.
Yeah, -7. So then I get -4 minus 3y equals -7. Plus 4 on both sides, -3y equals -3, y equals 1. So Nate, did you find y first and then do x?
Yeah, so what I did, I guess it was initially a little bit more work, but it worked out pretty quickly, was I multiplied the top by 3, everything by 3, and the bottom by -3. So then once I got it down, it was really easy. It was -11y equals -11, just because.
That's fine. You mean -2 on the bottom though, right?
Yeah, -2. That's what I meant.
Okay.
And then I just added.
Yeah. So so what I tell when I teach it in Algebra 1, I always say this chapter section is the choice of options. You have a lot of options, and sometimes that freezes people up, where they have too many options. They just rather have one option and go every time. But you have to decide which way is the best for you. So I'm going to give you a practice one, guys. Everyone try it. This one will force you to multiply both the top and the bottom. So please try it. I'm going to go to the, just going to get some water. So I'll be right back, but everyone should be practicing.
Before you go,
yes.
Before you go, I have a question about, on a test, will you require us to use one sort of method to solving these, like substitution and the subtraction?
I'll get back on you on that. Maybe I'll put one problem, like try solve this with substitution. One problem, solve this by elimination, and then the rest of the test will be choose your own method. Especially like word problems, I will not force you a particular way. Let's say that for sure.
Thank you.
No problem.
Also, just to clarify, you can add or subtract. Like you could choose which one you want to use, right?
You want to choose the one that causes it to disappear. So whether you add or subtract, it should be the right choice. But either one could be right depending on the situation. Just a very quick example, like if some reason you had like a -3y and a -3y, let's say, that case I would probably add because that would cause, or I'm sorry, I would subtract because that would cause it to be 0.
Yeah, I just wanted to clarify that you don't always have to add.
No, you don't always have to add. It's just whatever gets you to 0. Again, choice, whatever choice you choose to get to 0.
Got it.
Yeah. I'll be right back. I'm just turning on my camera so I could get up in like 2 minutes.
You forgot to mute yourself. You forgot to mute yourself.
My bad, man. So let me go back here. Let's do guess I could just do 4 and 3. I could technically do 5 and 2 also, or 2 and 5, if you want to eliminate the x's. Same thing. So 20x plus
Do you
12y.
want us to put the answer in the chat?
Yeah, do that. But I'm just going to do it out. So and then we could just compare answers. 9, 18, 36. 6x minus 12y equals 14, 28, 42. They are different they're opposite signs, so we add that. 26x equals 8, 7. Okay. X equals a nice clean 3. Plug it into one of the originals. Seems like the bottom is a little smaller. 2 times the 3 I just found. Minus 4y equals 14. That's 6. Subtract 6 on both sides. That's 8. Negative 4y equals negative 8. Or positive 8, my bad. Then y equals negative 2. So 3, negative 2. Let's check the chat. So most people got it right. Yeah, it seems like most people got it right. All right. Wait, is this the same as the previous question? No, it was negative 3, 2. All right.
Polarity reverse.
Mm-hmm. Different coordinates or different quadrants. Yeah, that's it. Again, if you did, I'll just do it in red. 2 and 5, that would still get you the same answer. So if you got 3, negative 2, I don't really mind what method you took to it. Just do elimination. Did anyone have any questions on that real quick? Okay. Okay. So a quadratic and a linear equation. So one of these equations are quadratic, the other one's linear. Now, just a reminder, when I have a quadratic equation, that's that parabola shape. When I have a linear equation, that's that straight line shape. Which means in these situations, with the blue straight line, you could either have 2 solutions where it crosses the parabola twice. You could have 1 solution, hits it at a what we would call a tangent line, and 0 solutions. It doesn't hit at all. This one in this case will be a 2 solution, and then I'll show you an example of very quickly a 0 solution. All right. So for these type of things, especially since you have quadratics, you're not going to be able to line up the variables very cleanly. So the best move is to do substitution. And especially with quadratics, whatever is your squared value, it's going to typically be your x. You want to get that all in one equation. So I'm going to separate my y and get y by itself, which means I could just add y on both sides and then subtract 1 on both sides. You could technically also subtract x squared and add x and then multiply everything by a negative. Both would work. Either way, I'm going to get on the top x squared minus x minus 1 equals y. I want to isolate the y. Because this y is isolated, I can substitute it into the other equation. So I get negative x plus my substituted x squared minus x minus 1 equals negative 1. Whenever you're solving for quadratics, the best thing you want to do is get the answer to equal 0. You want your solution to be equal 0, and you want to combine like terms as possible. So I'm going to add 1 on both sides. I'm going to plus 1 on both sides. And then I'll just combine these terms. So I'll get x squared minus 2x. This cancels out to 0, and that equals 0. Now from here, you can factor out x. Again, it has to equal 0. Don't forget that. And then from there, you could solve. This is going to be x equals 0 on the left, and that's going to be x equals positive 2 on the right. Remember, you could split and solve each one individually. But remember, we're looking for coordinate points. So we have two x's. We also need the y's that go with it. So I plug in x in here. So -0 plus y equals -1. So that's clearly 0, -1. And here, I'm going to plug in the 2. -2 plus y equals -1. So add 2 on both sides. So it's going to be a positive 1. So 2, 1. So you're going to get two solutions, which means it kind of crosses like that, where this point and this point are two different places. This could be 0, let's say -1, and this could be 2, 1. Just an example. Right? Any questions on that? For this particular example, it was very nice and it became like a two-term thing. But you could technically have the end solution be something like this, x squared minus like 2x plus 3, let's say. And then you have to do actual factoring. That could happen.
Could you have it like multiple, instead of x equals 2 and x equals 0 and x equals 2, could you have like 3 or 4 solutions and you have to find a lot of pairs? Or not really?
For a quadratic and a linear, a combination like this, no, because just look at it physically. This straight line could only hit this curve 2 times, no matter how high it goes.
You
can
know,
hit it
exactly. For the line test, we like took a pencil and you have to go across, right?
Yeah. So it's the same concept. It's like physically, the straight line can only hit it twice. So only here. When we have more variables, like 3 or 4 variables, which we'll eventually get to, that's section 0.3.4, then you could have crazy amount of answers at that point, because then you're talking about like 3D. Okay. All right. And here's a case of no real solutions. This is a quadratic version of it. I'm going to show you also, I'll just make one up real quick, a linear pair. But something like this, a quadratic solution, as I showed before, you have a parabola like this, and this indicates that the line does not hit it at all. The line does not hit it at all. So here you would try to do the same thing. You're going to separate the y because the x squared is here. You want to separate the y. So 4 plus x, or x plus 4, doesn't really matter. Plug it into the bottom. Now you get on the bottom, x squared plus, I'll rearrange it, plus x plus 4 equals 3. We can't have that. We want to set it equal to 0. So x squared plus x plus 1 equals 0. So your first instinct is to factor it out. What multiplies to 1 and that adds to 1. Sadly, you can't make a correct combination for that. So when you're in doubt, the best thing you could do is a quadratic equation. If you don't remember a quadratic equation, negative b plus or minus the square root of b squared minus 4ac over 2a. So what we get is -1 plus or minus the square root of 1 squared, which is just 1, minus 4 times 1 times 1, which will just be 4, over 2 times 1, which is just 2. Now, when you look at this, we have something inside the square root called the determinant. This thing, 1 minus 4, ends up being -3. As soon as you see that the end result inside the square root is a negative, you know that means it has no real solutions. Technically has imaginary solutions, but I'm not asking you to find that. So in this case, this is no real solutions. As soon as you see something like that, you're down to say it. No real solutions. But you have to show that to confirm it's no real solutions. It could be something that's not factorable and you could just have decimal answers. So that's why you couldn't factor it. You have to show that with some sort of quadratic evidence. You could technically use completing the square too, if you're more comfortable with that. I'm not going to go over that though.
Can you stay on this slide for just one more second?
Yeah, of course. And any other questions you could take it. Again, the reason you know it's no real solution is because that negative inside the square root would cause an imaginary number. So that's a case of like a quadratic and a linear. One thing that you guys went over, definitely at least in algebra 1, is two linear equations not being a solution. So I'll do like x plus y equals 3, x plus y equals 2. Let's say something like this. So here, it seems really easy to elimination, especially since I wrote it like this. So I'm just going to subtract down. You get 0, 0, and 1. So 0 equals 1. So when this happens, this occurs when you do either substitution or elimination. If you did substitution, you will get this result also. This occurs when you only have constants left. All the variables cancel out. And what you're left with something that does not equal each other. So 0 does not equal 1. Because 0 does not equal 1, that's not a real statement. So this is also a no real solution. Okay. And then how this looks graphically is that here's a straight line that looks kind of like this, and here's another straight line that looks kind of like this. And I didn't draw it perfectly, but basically both lines, anyone remember, are called what? Starts with a P.
Parallel.
Parallel, good. They'll never intersect. So that's a no solution. And you show that if you're showing the constants not equaling each other. Now that's a no solution. There's one more type of pair of solutions. So we have one solution, two solution, no solution. And technically the last one, you might think it's 3, maybe you think it's -1. It's going to be all real solutions.
Infinite solutions?
Good, infinite solutions. I call it all real solutions. Infinite solutions is totally fine.
So y equals 0 type thing?
No, not necessarily like this. Let's do
As in,
x.
like, I mean, as in you have the equation y equals 0.
The equation y equals 0 might not necessarily cause a all real solution. I'll show you an example. So x plus 2y equals 10. Let's do 2x plus 4y equals 20, let's say. Now I already pre-fronted and said this is an all real solution. So you kind of know this is going to be weird. But let's say you don't notice right away. Let's say you don't notice that something's going to go weird. Here, it looks set up for elimination. I'll multiply both the top and the bottom, or just the top by 2. So my top becomes 2x plus 4y equals 20. And my bottom equals 2x plus 4y equals 20. At this moment, you will be able to see, wait a second, I literally have the same equation. So because I have the same equation, that means these two lines overlap. So they actually are intersecting at every possible point. Now, you could see that as soon as you show that both equations are the same, you could stop and just say all real solutions. A symbol for that kind of looks like this R with a double back. That's a symbol for all real solutions. If not, you just write the words all real solutions or infinite solutions. But let's pretend, let's say you're in the test, you're like way too focused. You're like, nah, I'm not thinking that at all. If you were to do the subtraction, you'll end up with 0 equaling 0. So when you see that is a true statement, 0 equals 0, that also means is all real solution. So you could stop here and stop and say all real solutions. But just in case if you don't notice that right away, once you eliminate, or you could use substitution, you will get the same solution. You get 0 equals 0, or like 1 equals 1, or 2 equals 2. You get a true statement, like 2 equals 2. That's a true statement no matter what. That means no matter what, your answer is a solution. All right. So that's the end of today. I just want to know, does anyone not have a book with them and needs me to post the pictures? If not, it just makes it a little easier for me to post the homework. If you need me pictures, just tell me. It doesn't seem like it. All right. So the key here is just today I'm going to post homework. On Thursday, which I think is the next time we meet. If it's not, we'll do it Wednesday. First half will be more practice of this. Second half will be going over the test with people, just making sure your answers make sense to me so I can give you the full credit that you deserve. Okay? Otherwise, everyone type here for your attendance and then have a wonderful day.
Thanks, Mr. Taylor. Going.
You too, man.
Thank you.
No problem.
Oh, wait, we have to send it to everyone? Got it.
I just need it in the chat log. So you send it to me privately or not, I don't care.
Never mind, I did it anyway. Okay, thank you.
Bye.
No problem.
Bye.
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 Mr. Sewell,
What up, Jacob?
I have a question on.
Mhm.
It was like one of the beginning problems we did.
Oh yeah, sure. Let me stop recording so then you can just ask me about.